All right, ready to dive deep. We're taking on SQL today. Databases, I know, might not sound like the most exciting thing.
But trust us on this one.
It's actually pretty fascinating stuff and so relevant, by the way,
I
to
love it.
how we all live in the digital world these days. So
What?
no need to be a coding whiz, by the way.
Not at all.
We're going to break it down, make it make sense for everyone. That's the goal,
Yeah.
right? To walk away from this and be like,
To have that aha moment.
have those aha moments.
Absolutely, yeah.
Like, hey, I get this. This is actually...
Oh, I can use this.
I can use this.
Yeah.
Exactly. All right. So our guide for this deep dive, we are working with Lecture 3 SQL.pdf.
Right.
But don't worry, this isn't a lecture, all right? This is
More of a conversation.
Exactly.
Exactly.
It's a conversation. So, I mean, where do we even begin? We're talking about a language that talks to data.
Yeah, so I think a good place to start is with the idea that SQL is what's called a declarative language,
Okay.
which sounds complicated,
It does sound a little jargony, yeah.
but it's actually quite simple.
Okay.
So imagine you're at a library
Okay. I like where this is going already.
and you want to find a specific book, right? With SQL, it's like going up to the librarian and saying, hey, I need a book on the history of ancient Rome. Can you help me find it?
Right. Right.
So you've declared what you want,
Right.
the information you need.
You're not telling them how to find the book.
Exactly. Exactly.
You're not saying, like, go to this aisle, this row.
Yeah, like go to aisle 3, shelf 5, book number 27. You're leaving all that how to the expert,
Right.
the librarian who
Yeah.
knows the library like the back of their hand.
That's a really good analogy.
And that's what SQL does.
Okay.
It lets you focus on the what
Okay.
data you need, not the nitty-gritty how of getting it.
Hmm.
The database system, kind of like our trusty librarian, handles all that behind-the-scenes magic.
See, this is why people talk about SQL as being very elegant. Yeah.
It is. It is. It's about expressing your data needs clearly, concisely, and then letting the system do the heavy lifting.
I like it. Okay, so let's start breaking down some of the building blocks of this language.
Okay.
And I think a good place to start is with this idea of tables.
Yeah, definitely. So tables, really the foundation of any relational database. Think of them as well-organized containers for your data, structured in these neat rows and columns.
So kind of like spreadsheets that we're all familiar with.
Exactly, yeah, like a spreadsheet. You've got your rows for each entry, columns for different types of info.
Okay.
But unlike a spreadsheet where you can kind of put anything anywhere,
Right.
SQL tables, they're much more structured, rule-oriented.
Ah, so that's where that structured part of SQL really comes into play.
Exactly.
It's not just about organizing the data, it's about doing it with a very specific set of rules.
Exactly.
Yeah.
And that's where the power of SQL really lies. These rules, or constraints as they're formally called, they ensure data integrity, consistency, prevent errors, and really make your data reliable.
Data integrity, consistency, rules.
This is starting to sound serious, man.
It's about making sure your data is accurate and reliable.
Okay.
That's it. Think of it this way. If you were building a house, you wouldn't just start piling bricks on top of each other.
Yeah, you need a blueprint.
Exactly. You need a plan, a structure to make sure everything's sound and stable.
Right.
And that's what these SQL constraints do for your data. They provide the blueprint for your database, making sure everything's in its place and that the data itself makes sense.
Okay, I'm with you. I'm with you.
Yeah.
So how do we actually go about setting up these rules, these constraints, when we're building our SQL tables? It's like we're crafting the rules of a whole new world.
Right.
But instead of magic wands and mythical creatures,
Yeah.
we're dealing with data types and constraints.
Yeah. Yeah.
Ah.
It's like we're building, like you said, right.
Yeah. It's like we're architects of data. And it all starts with this command create table.
Okay, so this is where it gets hands-on.
This is it.
Like we are actually,
This is where the rubber meets the road.
yes, we're defining the structure
Yes.
of our data containers.
Yeah, you got it. So you declare the table's name, and then inside parentheses, you list out each column and its data type. Kind of like, assigning roles to characters in your world.
I like that. Okay.
Right.
So if I'm building a table to keep track of all the books I want to read,
Okay.
I might have columns like title, author, genre. What kind of data types would those be?
Great question. So in SQL, choosing the right data type for each column, that's crucial. For title and author, you'd probably use varchar, which can hold, text strings of varying lengths. And for genre, you could also use varchar. Or if you have a predefined set of genres, you might use something like enum, which lets you specify like a fixed list of possible values.
Oh, interesting. Okay, so it's about like picking the data type that best fits the kind of information
Exactly.
that you're storing.
You got it. Now imagine you want to make sure that no two books in your table have the same title and author.
Right.
Right. That's where constraints come in.
Okay, so back to those rules.
Back to the rules.
We were talking about.
Yeah. So how do constraints help us here? We could use a unique constraint on a combination of, say, the title and author columns. That would ensure that each book entry in your table is unique. Just like, in a library, no two books are exactly alike.
Right.
Right.
That makes sense because I wouldn't want to like accidentally add the same book twice
Exactly.
to my table.
You got it. But what about some of those other constraints that we kind of glossed over earlier, like not null, primary key? They sound kind of important. They are. So not null, that's like that friend who's always reminding you, like, hey, fill in all the required fields on the form. It makes sure that certain column can't have empty values, which is super important for data integrity. So for your books table, you'd probably put that constraint on the title column, right? Because a book without a title, it doesn't really make sense.
Right. It's like those online forms that have those little like red asterisks, right?
Exactly.
Yeah, required fields. You got it.
It's like SQL's looking out for us.
Exactly. SQL's got your back.
Yeah.
And then there's primary key. That's how you say this right here. This is how we uniquely identify each book in our collection. It's like giving each book a unique catalog number that the library, or in this case, the database, can use to instantly find the right info. And often this would be like an auto-incrementing numeric ID, but it could also be, a combination of other columns, as long as that combination is guaranteed to be unique for every row.
So it's like the Dewey Decimal System.
There you go.
But
Okay.
for our like custom-made book database.
I'm starting to see how all these rules, these constraints,
Yeah.
they all work together to keep our data
It all comes together.
tidy, organized, and like you said, most importantly,
Accurate.
accurate.
That's it.
So, okay, we've built these like amazing data containers now,
We have.
but we need to furnish them, right?
That's right. That's where DML comes in, the data manipulation language. And this is where we go from like architects to interior designers. We're adding, we're updating, we're rearranging the data itself.
I like that analogy, yeah. Okay, so what are the tools that we have at our disposal?
All right.
What are the verbs, the commands that DML offers?
So the core commands are insert, update, and delete.
Okay.
Pretty intuitive, right?
They do. Like they map onto what you'd expect them to do from regular English.
Yeah, exactly.
So to like add a new book to my to read list, I'd use insert.
Exactly. You would write insert into books, and then you specify the columns you're filling in. So in this case, like title, author, genre, and then you'd use values to provide the actual data for those columns.
So it'd be like insert into books and then in parentheses title, author, genre, values, and then like the actual title, the actual author.
Yeah, exactly.
Did I get the syntax right?
Yeah, you got it. You're a natural. And just like that, boom, new book added to your database.
Okay, that's cool.
But let's say you made a mistake
All right.
or the information changed. Like Tolkien comes out with a director's cut.
Okay.
Right. We need to update that. That's where your update comes in.
So update is my editing tool. Exactly when I need to like tweak the data.
You got it. You would specify the table, the columns you're changing, the new values. Crucially here, you'd use a where clause to pinpoint the exact row you want to modify.
Okay, where clause, that's sounding familiar. And that seems like it's pretty powerful.
Oh, it is.
Because it's how I'm making sure I'm like editing the right book and not like, changing every fantasy novel
That's the key.
to have a director's cut. Yeah.
Exactly. Think of where as like your search filter within the database. You can use it with all sorts of conditions, finding books by a specific author, books published before a certain year, or even like books with titles containing certain keywords.
Okay. I'm following. And so then what if like a book totally falls off my radar? I'm like, get out of here. I want to get rid of it. That's delete.
That's it. Delete. It's gone. Although, word to the wise, with delete, especially with where clauses, double check those conditions because you don't want to accidentally wipe out your whole reading list.
It's like that moment of truth when you're about to hit like empty trash on your computer.
Exactly.
You're like, wait, hold on a second. All right, so we've done like adding, editing, removing data.
Right, we've got that covered.
That's super useful, but I'm guessing like the real magic is in how we like find and retrieve specific information from this database that we've built.
You're right. That's where the select statement comes in. That is how you ask your database very specific questions and get back nice tailored answers.
So it's like Google, but for my own personal
Go.
data store. Okay.
Exactly. The basic structure is select from where. You select the columns you want, you specify the table with from, and then you refine your search using where, just like we were talking about with update and delete.
So if I wanted to find like all the fantasy books on my reading list, it'd be select title from books where genre fantasy.
Nailed it. And you can get super specific with those where clauses. You want books published after 2010 by a certain author. SQL's gotcha. You need to sort those results alphabetically by title. No problem. Just add order by title ascending.
This is so cool. Oh my gosh, I'm already like dreaming up all the ways that I could use this. Okay, we should probably start to wrap up, but any final thoughts for our listeners before we do?
Remember that library analogy?
Yeah.
SQL is like having your own personal librarian for all your data, no matter how big or small. It really empowers you to organize, manage, and just pull out those insights that you need.
Yeah, like we've learned this secret language to talk directly to data, which is amazing. A huge thank you to our expert for walking us through this deep dive into the world of SQL. And to our listeners, we hope you found this as fascinating as we did. Keep those SQL engines running, and we'll catch you in the next deep dive.